Hey, this is OXDF, and today we're looking at Advent of Code 2016, Day 20, Firewall Rules, as part of the Revival of Code 2023. Let's take a look at the challenge. You'd like to set up a small hidden computer, blah, blah, blah. So a bunch of story. And basically we're going to get a bunch of IP addresses, except for they're not shown in the normal 4 numbers separated by dots, but rather just numbers 0 to 4 billion. Billion? 4 billion. Inclusive. And then we're going to have a list of firewall rules that are just a start and an end range, and we need to process those such that, this would be 5, 6, 7, and 8 are all blocked. This would be 0, 1, and 2 are blocked. This would mean 4, 5, 6, and 7 are blocked. And so the question is, what is the lowest value IP that is not blocked? Let's go ahead and jump into VS Code. First thing we want to do is pull I'm going to use my genday script here. So I'm going to pull the input for myself, as well as make some stub files so we can do some testing and some solving. Let's see, let's take a look here. We've got about 1,000 lines here, and they're all just giant number ranges. I'm actually going to switch off of this for a second and pull up some images here to show you, because I want to walk through the different some different examples of how we're going to think about this one, because this is one that if we think about it ahead of time, we can make our lives so much easier. So I used Manum to just generate some random ranges, just throw ranges on a graph. And I did it in such a way that I could specify the number of gaps. So in this case, there's 1 gap at 9, as well as the range here. So if you look at this, what we can start to get a feel for, okay, there's a gap at 9. What does it mean for there to be a gap at 9? Well, it means that all of the lines to the left of the gap are completely contained there, and all of the lines to the right of the gap are completely contained there. And so how do we algorithmically find that? And it's tempting to try to sort by, maybe sort by low start point, and then pick a high point based on, move up to that range and move to the next one. But really what we can do is we can treat the start points and the end points completely separately. And by that I mean, if a point is going to be after a gap, then let's say it's the 6th, in this case, let's look at it, 1, 2, 3, 4, 5. So the 6th point is the 6th starting point is going to be the point we get to after the gap. For that to be after a gap, we need to know that all 5 endpoints below it are less than it, and actually less than, it minus 1, right? Because we need it to be 8 or less when it starts at 10. And now we need to know there's 5 endpoints below there. So we can just look at the lowest 5 endpoints. In fact, we can look at the largest of the lowest 5 endpoints. So effectively what we can do is we can sort the start points and sort the endpoints. We can pull the first start point off, because basically that one it's either 0, or if it's not 0, we found our gap, right? Then 0 is our gap. And now we can loop over the rest of the start points, pairing them up with the endpoints, so start point 1 with endpoint 0, start point 2 with endpoint 1. And if start point 1, if the given start point is greater than the endpoint by more than 1, then we found a gap. Let's look at another example here. Here's another example with the gap at 9. And we can see here, we've got 3 starts and 3 finishes before we get to our 4th line, which starts at 10. And we can say there's a gap there, because if we look at that 4, compared to the 3rd endpoint at 8, it's more than 1 greater than that, and we get a gap. We can look at some examples with 2 breaks, and you see the same thing, right? So we have our 4th line from 7 to 8, and that's going to be our first identification of a gap, because it's going to we'll look at the greatest endpoint before it, which is at 5, and we look at those 3, and we got it. We can step through some more. Here's an example. Here's and the 4th one here is an example. Another one with 2 breaks in it, which is a break at 6 and a break at 14. And again, we can just look. By comparing starts to that previous endpoint, we're going to be good. And we just think of them independently. Here's one with 3 breaks in it. And again, it's the same thing. Now it's important to look. If we look at the very second line, so the one that goes from 2 to 3, we can see that if we look at, the 2, is it greater than the previous endpoint at 1? It is greater than, but it's not greater than by enough. And we actually need to be greater than by more than 1, because otherwise, this in case it's not a gap. If we were allowed to do like fractional IPs, 1.5 would be in a gap, but because we can't do fractions, 1 and 2 are both covered, so we're fine there. Yeah, so let's get back and actually do some coding here. We can go here and we can start to, let's see, we're not going to need any of the path stuff for this. And let's see, I don't even think we're going to need any parameterization. We're just going to say part 1. We better parse. We are going to need to parse. So actually, let me come back up here and do a skip on this for now. And we can do def test parse. And what do we want the input to look like here? I guess I'm going to define myself a fixture. I guess I could have used file stuff, but we'll make ourselves a fixture. So we'll do pytest dot fixture def example, and now we can say puzzle input equals. I better go grab it from here. We're just going to do this really simple example like this. Perfect. And now we can say return. In fact, let's put a line. They always put a line at the end, so we'll put a line at the end. Puzzle input. And if we test parse, we're going to pass in example as there. So now example will get this puzzle input. And so now we can say, what do we want it to look like? I want to just parse it into a series of like pairs of integers. So we'll say assert aoc.parse example is equal to, and we'll just put these in pairs. So it'll be 5, 8, 0, 2, and 4, 7. Sweet. Okay, so we should be able to, I'll use my F5 key here. I've got pytest configured so that I can run pytest through here. I'll include a link to that video. And we've got one test failed. Perfect. We're asserting that none equals that. So perfect. We haven't written our test yet. We haven't written our code yet, so we expect the test to fail like that. Now we can do our parse up here. And all we need to do is, let's see, we'll take puzzle input dot split, better do a strip just to make sure, dot split lines like that. And we can actually loop over those. I think we'll be able to do this in a list, might be able to do this in a list comprehension. So we'll say x for x in, or really we could do line, L for line, I guess, it's probably better. Line for line in. So for each line, we are going to split it on the dash. And we know that's always going to just produce 2 items. So we're going to make an assumption that that's good. So we can do a map int onto that. So now we're going to get 2 integers back as a map object. And then we'll just turn that into a tuple. Like this. And like this. And this, I think, is going to give us our list of tuples. So we can just return this. And let's F5 to see if we pass. And we're passing our test. So we're parsing. Cool. Let's do our test. Now we want to do our part 1. We'll take example again. In this case, we're going to pass in example here to the parse and get the parsed input. And we're going to pass the parsed input to parse 1. And we're going to get, let's find our example. The firewall allows 3 and 9. The lowest number will therefore be 3. So say this is equal to 3. And we F5 this, and we now should have a failing test for none equals 3. Perfect. Let's go back here. So how are we going to handle this? So this is where we can work off what we talked about. So I'm going to do first comma starts. And this is kind of a cool notation. I can put this star here, and that'll basically say, well, here, I'll just, let's see, equals sorted S for S in data. Oh, S for S, let's do S comma like that. So basically what we're going to say is for each data, we're going to read into S, and the underscore kind of just means throw it away. So we're going to grab, for each pair, we're just going to grab the starts, and we're going to put them in there, and we're going to sort it. And so we'll have the first start here, and then the rest of them will be in starts. We can do the same thing here with ends. We can expand there, say, give me all of them, and then last equals sorted E for E in, E for like that in data. we're going to loop over data again, this time just grabbing the E values and saving them, sorting them, and keeping the last one off separately because we want to handle that differently. We can say if first is not equal to 0, return 0, because if our first start point isn't 0, then 0 is the answer. Now we can do for s comma e in zip starts ends. Basically, we're going to get a start. We're going to get a start and the previous end because we've already ripped the first start away and we did not rip the first last away. If s is greater than e plus 1, we can't just do e. Remember we did that and they showed that in the examples. Return e plus 1 because that'll be the gap space. And it's important to base that off of e, not s, because hypothetically we could have a gap of 2, and so we'd want to get the first one. I think that's probably it. Might solve. We did solve. Let's go up here. Oops, that's not here. Let's go here. Change it to current file, and F5 this, and we get an answer. Grab it and paste. Sweet. Part 2. How many IPs are allowed by the blacklist? Cool. So we've got to run this to its completion. For the sake of initially starting here, we're gonna start by copying this and modifying it. It might be worth coming back at the end to combine them, but for now, let's do this. So we need to keep a count. In fact, count will equal first. So we can get rid of that. So if the first is 0, we start at 0, but if the first is 5, well then 0, 1, 2, 3, and 4 all fit. So we can just start their count there. So now we say, oh wait, hold on. We need to come back here. We need to write tests. We don't need any of this. We just need to push in example, and then we expect the example to return 2 because 3 and 9 were the answers. So now if we save this, if we run this under PyTest, did I actually return anything here? Comment this out just so we, that's not what I wanted. Comment this out just so we return nothing. And now we can run PyTest and we've got a none equals 2. Perfect. Okay, so come back here. So we got our count is equal to first. At the bottom of this loop, we are going to return count. Uncomment this now. So for each of our things, when we find a gap, that's the gap, we are going to not return, but we're going to count plus equals s minus e. S minus e. So if the gap was 8 and 10, so 9 would be 1. We want to do 8 minus 10, or 10 minus 8 minus 1 to get rid of it. So we want to do like that. And then we guess we need to check at the end if last is less than max val. We kind of just ignored the end in the last one, but let's see, count plus equals max. In fact, we can do the same thing we did here, plus max val minus last. We don't need an if, and we're gonna need to pass a max val in here, so we can say max val equals, and let's just do max val. We'll always state it. So for part 2, so we can come here. We should better update our test here. So parsed input equals that, and in our example, the maximum value is 10. So if we F5 this right now, we get 3. Let's see. Is max val 10? Look at the example. Oh, look at our input. Oh, nope, look at our puzzle input here. 5 to 8 to 10. Was 10 not meant to be included? Is max val 9? Yeah, 0 through 9. Okay, sweet. So I just have a max val problem like this. F5. All right, we're passing. Let's test that for our input. We're going to need to do this here. So part 1 is that. Part 2, we need to know the max val, which is that 4 billion number. Grab that, pass it in, and I think we're in good shape. We parse the data. We call part 1. I'm still under PyTest. Let's change this back to current file. 101. I'm not sure if that's, I have no intuition for if that's good or not. It's good. Let's take a quick look and we can combine these two, I'm sure. Let's see. So we're going to do def run equals def run data max val. And let's just do this. Grab you. Solve part 1/2. We will just come down here and put count. Let's see. Maybe we'll do part 1, part 2 equals none, comma first. So now we loop through here. When we find our thing, if not part 1 equals, and it's just e plus 1. And then down here, we're not going to do count. We'll do part 2 is that, and then return part 2 plus that. We'll do part 1, comma there. And so now we should be able to say solution 1, comma solution 2 equals run data 4 billion number. Comment those out. Give that a run, see what happens. Same numbers. So we can get rid of our part 1 and part 2 here. Our tests will probably need to get updated here if we do that. So we can. I'll probably clean that up for the repo, but I don't think it's super interesting to watch me do it here. So I'm going to call it here. Thanks for hanging out with me today. I will talk to you next time. Bye.